Hello everyone, and welcome back to Before the Basics Computing. So, I wanted to go over, real quick, how everything kind of works. Well, more like how I went through and tested all the hardware. That way you would kind of know how to do it if you were trying to do this yourself. So, uh, first off, I had to make a little change. um, Write was not working for, it was a little bit flaky on the LCD, and it was a little bit flaky on the TFT. Well, actually, it just didn't work on the TFT. So those have now been moved. The TFT has been directly moved to the CPU only, and this has been moved to the LCD has been moved to. Uh, what am I trying to say? It's been moved. It's been moved to the same one that the VIA uses, so it's not clock enabled. Um, which is fine. And then for everything that is clock enabled on the right enable, it has been put through a. You can't really see it, can you? We get rid of that. Can you see it? It's down here. Nope, it's slightly off screen. Anyways, it's been put through a diode gate. So instead of using transistor logic, it uses diode and a pull up or pull down resistor logic. So yeah, it's the changes. But basically, that's allowed the whole board. From what I can tell, it's now stable at 2.5 megahertz. So that's doubled the speed, which is pretty nice. Let's go ahead and bring this back up. So let's go through and test some things. To be able to see the TFT, it's up here. And to really test this, that's not what we're doing here, right? It's not really gonna test it. What it's gonna do is it's going to turn it on, but we aren't going to be able to draw anything to it because the actual initialization for this thing, it requires like 64 bytes or something written to it, ridiculous, to actually initialize it. So we'll do that in code later. But for now, it's the commands to the TFT start at A0 and go through A7. So if we write a 1-1, that's a sleep out command. And here we go. Pay attention to the TFT. When we write a 2-9, which is a display on command, boom, it turns on. So this is what it looks like when it turns on. Like I say, I can't actually plot pixels or anything without fully initializing it, but that's how that works. And if we want to turn it off again, we can either use the sleep in command or the display off. The sleep in command is the one I know, which is 10. There we go. We've put it back to sleep. So we can see that the TFT works. For the rest of this, we're going to be testing all of this. Also, you can't see it, but I've got the USB board hooked up. And so I've looked through the data sheets and I've found basically the minimal things you can do to test it. So let's go back to where you can see things. See me again. Not that that's important. So basically what we need to do is we need to come into the SPI. This is the mode register. We're currently 00, which is fine. Device 0 is nothing. And it's actually designed to stay that way. So that way, if you need to deselect all SPI devices, you just go to device 0. And that does it. 0 is the fastest clock speed. So F is the slowest. It's kind of like a clock divider, basically. But it's just selecting a different clock mode up on the thing. Up on the SPI driver. And the fastest speed that this version can do is 10 megahertz. Because of the way it's ended up being designed. It's supposed to be 20 megahertz, but of course I can't run that fast with the chips that I have. In a printed circuit board version, though, it might be. So there you have it. So what do we actually want here? We want to test some stuff. So let's go for an easy one first. F is going to be the static RAM, is one of the static RAM chips, as can be seen here. Um, C, D, E, or F is a static RAM device. Let's just scroll down here because this is all the SPI stuff. So if we select that, and then, so 09 is where you send and receive data. If we send the command 05, this says give us, this is to read the mode register inside the SPI static RAM chip. If we read right now, it's going to give us FF. So what we want to do is send an FF. This actually reads the byte in. And then if we read the data, we'll see that we get 40. And that's what we expect because that's the mode for SPI. Because these chips can also do SDI and SQI, which is basically 2-bit and 4-bit at a time serial modes. So that's what we expect. Next up, we can check the ROM. I actually haven't tested the ROM, so hopefully it works. Basically, if we go to device, let's see, 1 or 2, let's try 1 at maximum speed. Okay, and then we send the same command because they have the same stuff. They have the same commands. And then we need to send, of course, FF to make sure that, you know, we did the thing. And then we read. Well, I'm not entirely sure what the mode register is supposed to be for these, so 00 might actually be correct. Because I'm not sure what that's supposed to give back. But at least it gave something other than FF. FF would mean it did not work. So, yeah, let's go ahead and send, not send anything, but go ahead and deselect stuff. I guess I didn't do that before, but it's okay. You can do it without. So we're just gonna assume that's probably right. We could try the other device just to see if it's any different. Make sure that this sent FF. Okay, it did. Oh wait, and then send FF and read back whatever it is. 00. So apparently that's its default mode, I imagine. Because they both sent back the same thing. So it seems to be consistent and it seems to be correct. I don't know. Let's go ahead then and move on. So what we want to do next is go ahead and select Ethernet. Ethernet's a nice, easy device to test, which is the WizNet W5500 or something like that. That sounds right. So to do that, it's device 5. So we want to send 00 39. Now what this is it's an address into the register bank that we choose. 00, which is the command. This chooses register bank 0, which is the main register bank. It then also sets us to read, and I think there's one other thing it sets, but I can't remember. I can't remember what that is, but anyways, it's the command that we need to test. And then this should still be, whoops. Oh, that's right. It sends back like 1, 2, and 3 while you're doing this, so you know where you are. I didn't know that before, so this kind of confused me, but then we'd send an FF to read the byte that we asked for. And so if we see what that is, it's 04, which 04 is the, it's a constant at that register location hex 39. It's always 04 on these chips, unless if some new revision comes out and it changes it. But this is basically the version number. So that's that. So that's the WizNet chip tested. Next up is device. I don't know what that's all about. Status F5. Weird. We could do the SD card. What else have we not done? USB. Let's do USB first. A bit easier. So the Max 3421, I think it is, USB host controller. It can also go act as a peripheral. What you want to do for that is it has a half duplex and a full duplex mode. The half duplex mode uses the same pin for input and output. Full duplex uses different pins. We need it in full duplex mode. So the first thing we have to do is set full duplex mode, which is these two commands right here. So this one writes to the register that we've set, and then this writes the 10, which puts it in full duplex mode. And then we can read the revision number later. So let's go to device 7. And what we need to do next is do the stuff. So we want to write 8A, which is the command. We then write 10, which is what we want to write. We then need to deselect it. And now we can reselect it. And then we read the revision number, and hopefully I did everything right here. Now it will send us some status information back on that bit. Okay, and now we actually read it here, and we get revision number 13, which I have looked on the data sheet. That is the current revision. You could also get revision 01 or 12 or 02. But those apparently have certain bugs in them, so you do need to be careful if you have a different revision number than 13. That it's actually been that you're careful of those bugs that have happened. Yeah. Yeah, 13, as far as I know, is the most recent one, and it has fixed most of the bugs. So there's that. But this shows that our USB, we can interface with the Max 3421 USB host controller. So next up is, well, the most complicated one, the SD card. So for this one, we need to go into slow clock mode and device 0 for now. And the device number that it actually is device 4. And so from here, we type in this monstrosity of a command. Essentially, this is the command 0. The parameters of 0000, however many zeros there are there. But that's the parameters. This is the CRC, which needs to match this command in parameter packet, specifically for command 0, and the next one, which would turn off CRC checking. But yeah, the first thing you got to do is just send a bunch of... Oh, you know what? We need to... It's fine to send that, but we need to be here. What we need to do is just send... Basically, what we're doing is we're clearing the SD card. I think mine's well enough behaved that this doesn't matter too much, but you never know. Having a well-behaved SD card helps to check to make sure you're able to communicate with the SD stuff, because there are some that are not well behaved for SPI, and they are a nightmare to work with. So I have a well behaved SanDisk high capacity SD card, and it works well and works quickly. So what we now need to do, that was probably enough clocks to clear whatever it was doing. If it was doing anything, hopefully it wasn't. We need to go ahead and go back to the mode. Device 4. Okay. So we're going to send 40. Then 0, 1, 2, 3, 4. And you do need to make sure you send the exact amount there. Then send the CRC. We can go ahead and read that. I doubt it's anything useful. Yep. Okay, so now we send FF and read the result until we get a result, which I expected to get it here because it should have had enough time to do it. Yep, and there it is. 0, 1 means it was good, and it's gone idle. So that's exactly what you want. At this point, you've done a transaction, so you can deselect the SD card or whatever. But yeah, that just shows that we communicated with the SD card, because that's the result you should get. It should go idle after that command if you've done it right. It could give you something else if the CRC is wrong, or if the command's wrong, or other stuff. But this is the result you want. But yeah, that's basically tested all the extra hardware. The last thing on this board that has not been tested yet is high RAM and abort sequencing. I actually know that I'm pretty sure this works because I've ran into so many problems with it. I ran into another problem where I had these two wires were switched, and so I had to swap them back to make it work. But yeah, otherwise, that's everything except for the RXTX, but I'm pretty sure I can get that to work because it's just another SPI device. You throw it on the bus, it should work. That's the UART adapter that I have. But that should just, like I say, just work. Yeah. I don't think there's anything else to really test to make sure I can communicate with. I can communicate with the TFT. I can communicate with the all the SPI hardware. So that means Ethernet's easy enough, SD card's easy enough, ROM up there, RAM. We can do it all. So that means an operating system is probably next. When I say operating system this time, I'm not talking anything complex. We'll get into that. It's going to be bare bones, just helping me do some things. But yeah. So, until next time. Bye.